welcome on back to the game dev project. This is Devlog number 32, and a bit of a week this week. On Monday, I was working on optimization, so suddenly, when I was testing, I had this camera issue. When I would play, it would be super zoomed in. Couldn't really see what's going on. And I really couldn't figure out how to fix it. So I decided to scrap the old project and check out a clean project, see if that fixed the issue. Kind of took a while to download, and I had to fix a couple libraries in order to get it working. But I got a new project up and running, and it seemed to solve my issue playing the app. It would be normally zoomed out. So on Tuesday, I was able to get the fog post-processing effect working again in the new project. I spent time going down the rabbit hole of optimization testing and trying this and trying that. Over the course of the week, I was I couldn't tell if it was the editor or what, but all of a sudden I was reaching the ceiling of FPS. Not in 2D mode. 2D mode it was getting pretty low. It was like 50, but it was still manageable. You could still run and test in the 2D mode. But whenever I got in VR mode and put the headset on, this particular environment with the shadows, it would dip below 30, like 20 frames a second, 15 frames a second, and it just really unplayable, untestable in VR mode in the editor. So to test this, I actually did a build to see, okay, because I knew there's some extra overhead. The ceiling's a bit higher in a build, and it is true, like, even though it was running slow and untestable in VR in the editor, the build actually did achieve a steady 71 FPS, and it didn't display any signs of lagging or stalling or anything like that. So, you know, what's going on? Is it just the editor overhead? So, you know, doing my normal tricks like restarting Unity, restarting the computer. The only thing that actually helps a little bit, gives you a couple frames per second, is just setting it back to default, closing some of these extra windows that pile up, these extra tabs. But it still really didn't solve my problem. There's something else, you know, it's not just the editor, it's not just in VR mode. So this is the first real time where I'm actually working with a production level quality, you know, textures, lights. All my other work up to this point was, you know, just basic, you know, prototype testing with planes, gray boxes, simple textures, no lights. You know, just had one directional light. And this is the first time I'm really seeing performance issues, especially when it comes to testing in VR. I've almost come to the realization it's like you have it's almost like you have like a mobile or web application budget, but you're running it on PC VR. You know, it's like, and I can really understand a lot of developers' choices now why they tend not to develop VR games, because the budget's so slim for what you can do as far as graphical fidelity. Things like this, all these fancy stuff like specular lights and shadows and, you know, having a bunch of lights, you know, ray tracing, it's all very possible in 2D mode. The only problem is you can't, a lot of games on top-down in 2D, you're really limited in your view. You can't really see around you too much, kind of like Diablo, but in VR you can really see and look around your environment. So it's a real trade-off if you want to do top-down. So So once again, I was trying to figure out what's slowing the darn project down. I decided to check out another clean project once again. And this time I moved the project to my SSD instead of the hard drive, and upgraded to the newest version in Unity. Because the camera issue popped up again, and I think it was like something, maybe an old version of Unity or something. It was outdated, but that really wasn't the issue. Checking it out and getting the project running again on the SSD. Yes, it does. I'm gonna keep it on the SSD because it does load the project faster, and then the interactions are much quicker in general if the project is living on the SSD along with the Unity build. So that's a good optimization for my workflow, but there was still the camera issue, so something else going on. So basically, I wrote this little script, this little convenience script to basically switch out the camera profile. If it's VR, it would switch to 2D. If it's 2D, it would switch to VR. Well, if it just doesn't. It actually doesn't like if you had this set to VR as default and you're switching back to 2D. That's how it got stuck. So I kind of did away with that, and that fixed the problem. So tricky bug, but whatever. So by the end of the day, I was messing around with the lighting setup, and I had a somewhat decent result running in the editor by the end of the day and in the build. I kind of got excited, like, because I optimized the lights a bit, and it's like I went from a point light, which shines light in all directions and really heavy on the calculations of the walls and shadows and everywhere, down to a point light, which is a focus point of light. If we play this, before my understanding of a lot of things was really limited, I could see CPU, or I could see these things, but I didn't really understand what they mean, or how, what does it mean? So one of the things is shadow casters. Before I had a ton of shadow casters, like 240, really slowing things down. Yeah. So this is running on VR right now, but basically it's really I thought I learned a lot last week, but this week was even more diving down the rabbit hole of understanding, optimization and performance issues when it comes to Unity render engine, the URP, not just a monkey, basically before I'm just a monkey flipping knobs and settings in the not really knowing what all this stuff does, just, oh yeah, turn this on, flip that switch, really sitting down and understanding, okay, what the heck is an SRP patcher or a GPU resident drawer? What do all these things do? What do they mean for the engine, how it processes and renders the actual scene? New tools like let's see here, the analysis, the frame debugger, where you can actually sit here and look through what's taken so long and going from the draw calls, the batcher. It used to display a little image here, but it's not really doing that right now. But you get the point. It's like a deeper level of understanding of how this whole system operates. So I was working with sector occlusion. So basically it kind of worked okay in 2D mode, but when it was in 3D mode, it really didn't operate for some reason. It was not not very reliable. So I tried to give my tried out my hand with the actual. Let's see here, the actual Unity's built-in Umbra occlusion culling solution, which is pretty painless. Um, I knew kind of something about, with light baking, you have to be. What happened to this wall here? Went and disappeared on me. Must have turned it off. Anyways, the oh, because I just turned on occlusion, of course. So yeah, it's like, what happened to my level? It all disappeared. Well, that's because you can see the occlusion is working in some sense. Now, the interesting thing that I learned is that if you're testing in 2D, this field of view is much, much narrower, and that makes the renderer not have to hit all these different meshes and actually do draw calls for all of them, which really cuts down on the FPS. But the problem with VR is that the FOV is so damn wide, you cannot really manually say, hey, narrow it down so we can optimize. It has to be this way. And it's just taking, everything it hits, and then regardless if it's shown or not, it's processing rendering calculations. So the overhead of VR, so you really have to be aware of, like, when you start to throw in, so your meshes, the draws calls, I learned these meshes, draw calls, and then you add in lights, it has to draw another draw call on it, and when you add in shadows, there's more draw calls on that. So, and batches really equals draw call. So at the beginning of the week, I was having some serious batches issues where it was really dragging down my my FPS a lot. That said, on Wednesday, I got the Unity's built-in occlusion working, but it really didn't seem to help too much as far as optimization. Maybe, in fact, it seemed to even make it worse slightly. I'm not sure, but all said, got it working. On Thursday, I got to the point where I could finally test out my fog plane solution. I had to mess around with it to get it to work, but I began to test it out in VR, and this is when the actual performance really took a nosedive. It could handle... So basically, I figured out that if you want to test in VR in the editor, you have to disable shadows. So I went and wrote an optimization script, using my sector. Even though the sector occlusion doesn't work, it's good to still sectorize my levels so I can actually read from the graph and tell where my character is located at all times. So if he goes in a different room, I can listen for a notification. And I use that to say, okay, every sector now gets a listener and says, okay, if the player is not in your sector, turn off the shadows rendering. That seemed to be a good optimization. So once that was done, I pretty much figured out that, just disabling shadows in the editor allowed me to test in VR. So once I had that pretty much in the bag, I had the fog plane working again. So I put the fog plane here and I had a volume like I had before, but actually running it in VR, there's two problems. One, the actual post-process effect on top of everything, even without shadows, just destroyed the remaining FPS to where you're playing in the headset and it's just super framey, super choppy. The graphics are smearing, just totally no good. Yeah, the fog post-process effect was really designed for a 2D game. And also, I had to read the fine print of the package that says this is not supported in VR. So when testing in VR, the VOG was working, but it looked like total crap. The lighting for one eye was being rendered dimmer and different to the other eye, so you get this aberration effect that it wouldn't be rendered correctly for both eyes. So the fog effect is not supported for VR. So all that work and buying that package for the fog for this solution, only to figure out that it's not going to work, right? So kind of had to go back to the drawing board and say, okay, I have to come up with another approach for this. All through this, I've always, I'm doing a lot of optimization work because I'm afraid that I'm going to be going over budget. And I actually did a build with the fog effect just to see what it would perform like in an actual build. And it was dipping below the 71 standard. It was trying to go into 60, and it's just like, yeah, that's no good. It's not going to work out. But what concerns me is that I have this budget for production, and while it seems to work on the surface, if you add other things to this, like, AI enemies roaming around or a bunch of extra meshes and objects and stuff, without proper optimization system, I could easily see that budget getting overrun and the performance going below the acceptable, So I have to come up and really understand and come up with a system because I want to keep these things. Like, it looks really good like this with the lighting. I got it where I wanted it, but if I'm cutting optimization, then I don't get these nice shadows. And one of the big things is, real-time lights. Okay, no, shadows is one thing, but I have to have real-time lights because the baking on some of these textures, it picks up the baking light pretty decently, and that's an optimization. But for some of these textures, it has this texture in particular, this material, just with the baked light, it comes in all dark. You have to have these real-time spotlights shining so you can get these real specular highlights, right? This specular blue here, this, see how it moves in real time? And reflection probes won't do it alone. So it's like, I really want, at the very least, some sort of specular highlighting, and all this comes at a cost, but I want to have, but those, I think, some sort of shadows and specular highlight, if you can get that working in VR, that would make your game look good, even though it's pretty tricky to pull that optimization off in VR. I just don't want to give those two things up. I want to figure out some way to have these things, because without the specular highlights and without the shadows, the game looks pretty plain and boring. It's nothing to write home about. So I think it's essential, but pulling it off is another story. So so one of the ways I kind of thought about getting around this problem of being able to look, you're still constrained by the ceiling, but you can see over. So maybe instead you can only go back so far, maybe, and then instead of this complicated collider system where it, it's very rough and it transitions you down and through, maybe it has like a Zelda system where it's more simple and the whole wall is a camera collider, and then there's like if you go far enough into the other room, there's a trigger to to where it triggers to a point, like a smooth diagonal down. That's what I kind of imagine. And then if you go back, so it won't follow you into the room. It'll stop here, but if you go into the room far enough, it'll kind of trigger to that point, you know. So it'll be constrained to the room, but you won't have to do this complicated setup where. So it's a new system, but it kind of, you know, it'll kind of prevent you. The camera will be a big enough buffer, so you won't be able to see really to the next area. So no need for fog, but that's all for another time. That's because I'll have to rework the this solution since the fog didn't prove to be a good solution. So on Friday, I spent a lot more time trying to figure out how to squeeze as much FPS as I can out of a baseline, because I have to. So far, I have a bunch of rules. You know, this whole test level is kind of a staging area of like, okay, how am I gonna? It's like a blueprint for how am I gonna construct the real levels. All these like, you know, some of these walls need to be built this way, and you know, the textures need to be that way. I've come up with like a specification that would really assist me when I'm actually building the real levels, and it's like a system of environmental level design that'll really like kind of expedite the process. So I can get all my issues out of the way first, so it's like if I do come into issues, there's not going to be any major issues with the choices in design I've used for level construction. But I have to get this this balance between quality and performance right. So that's kind of my goal, to actually. So on Friday, I researched a tool called MeshBaker. It allows you to kind of take all these individual meshes and combine them together if they share a material. It kind of promised that you could just easily take this whole room and combine it into one object, and that it would create an atlas to correctly set the UVs and make it all one big object. But it kind of, I don't know if I had the settings wrong, but that didn't really work out. So I tried to get all the, you know, combined meshes of like these walls and these floors, all that share a common material. And in order to kind of, the idea being less meshes means less draw calls, you know, since it doesn't have to calculate a draw call per each mesh. They just calculate, you know, one. And I figured my my occlusion, if it's, you know, if it's just one, you know, big mesh per sector, that'll kind of, you know, it'll just either turn the whole sector on or the whole sector off. But I really got mixed results. In fact, I had issues with actual doing the builds. For some reason, the reflection probe wasn't picking up the combined mesh, and just a little, you know, odd little things. So real mixed result of that. I might mess around with it next week, and it might be a useful tool for in the future. You know, if you have a, you know, something else, but that's kind of where I left off last week, or this week. So by the end of the week, I was kind of feeling defeated. Like I really hadn't moved forward or made progress at all. But I only really moved forward in my understanding of how damn complicated the whole Unity rendering system is. You really have to understand like how all these systems work in perfect harmony in order to get like a quality look out of it. And it's, you know, a lot of things about optimization. I mean, it's such an advanced topic where it's like I had to watch video after video after video to really wrap my head around, you know, everything that's involved. to really solidify my understanding. And I've gotten a lot further. Um, Yet I still have to find that secret sauce, that secret setup that clever way of designing a level that really play well in the VR headset. Um, so I need to achieve that clear conclusion, to where I can say, can I have shadows? Can I have real-time lights? Will it fit into my budget? All that sort of work. So a lot more tinkering around and messing around, trying to get my design right with these lights next week, and hopefully I come up with something that I can start actually constructing the first pre-level. But that's about it for this week. Don't have really much more to talk about, so I guess I'll leave it there, and we will speak to you later. Bye.